and welcome to Aligned on AI podcast, where we have real conversations with business leaders about what's changing in their industries and where AI will actually help. Today, I'm joined by Steve Cassingham, based near Seattle in the US, who works with MYNT or MYNT Systems, a company designing and implementing integrated clean energy solutions for commercial and industrial buildings. Steve works at the intersection of technology, creativity, and sustainability, helping organizations rethink how energy is generated, stored, and used across their operations. In a world where AI, electrification, and data centers are all increasing demand for energy, the conservation about how we produce and manage power is becoming incredibly important. And I suspect today we might discover that energy is becoming the quiet backbone of the digital economy. AI might be the glamorous headline acts right now, but energy is probably the stage crew making the whole show possible. So today we're going to explore how the clean energy sector is evolving, how organizations are thinking about decentralized energy systems, how AI might support that transition, and what business leaders should really be paying attention to over the next decade. So Steve, welcome. We dive into all of that. It'd be great for listeners to hear a little about your own journey and how you ended up working in this fascinating space.
Absolutely. Karl, thank you for having me. So I'm so happy you mentioned energy as being this backbone of everything. That's kind of what drew me to the space, honestly. So my background's been in design and media and strategy, branding, kind of started ever since I was young. Grew up kind of in the Bay Area, a little bit around technology, and just was always fascinated by it. I remember the first iPod when I was a kid. I remember the first iPhone. I remember early computers too. And even as like a really, really young kid, because I'm a little bit younger in the technology landscape overall. But there's just always this fascination with how do you take this beautiful thing called technology that people developed and literally invent and put it out to the world, and how do you interact with it and see how it integrates? And usually that comes down to messaging. And so I was always fascinated with how do you communicate this really complicated thing in a simple way? And that's what kind of led me on this journey. So I worked a lot with, startups in Silicon Valley during the kind of bump of 2012, 2013, 14, that craziness there. And then I worked on my own company where we were designing and pretty much shooting series all around the greatest of all time of sustainability. So the innovations, whether it be, Sail GP, whether it be recycling nuclear waste to be used as form of energy or materials other than plastic. And all of these things kind of opened my eye to, you have this topic that we dubbed as sustainability, but is also mixed in innovation and circularity. And we're kind of putting them together. And to your point, what I noticed was energy was the backbone of most of that. It was like, well, you guys need a lot of power to do this stuff, right? They're like, yeah, we need a lot of power. Well, where does that come from? We get it from the grid. Like, okay, well, what about the grid? And then part of the good part about my job is that I get to be that almost that 5 or 6 year old is just kind of going, why? And I just get to
Yep.
keep asking that question. And it led me to really like, what is going to support all of this energy need that we do have, because it's so important. And that's a little bit more of my background. Generally, I spend a lot of my time thinking where ideas fit into society, designing around that, and then creating media and stories that can kind of communicate that in a meaningful way. So that's a little bit of background. I know we'll probably go a little bit deeper, but a
Yeah,
little bit
no,
of a
that's
windy
brilliant.
road, but a fun one.
No, that sounds good. That's really good to hear. So what attracted you to MYNT Systems and the work that they're doing?
Yeah, I'd been introduced to our CEO, Derek Hansen, I want to say 6, 7, maybe 8 years ago at this point. A friend of mine just said, "Hey, you've got to talk to this person. He's doing some really interesting things." And at the time, I was doing media, and we had a conversation that was supposed to be about 30 minutes. We talked for about 2 hours, and it went into so many different topics. And um, what they were working on building at Mint and what we are now, but it was, how do you build a decentralized energy grid for the future? Something where people can actually own their energy. Because I think that's one of the biggest things that maybe is kind of more prevalent in society, even outside of energy. It's like, what do you own these days? You don't really own your music because you're on Spotify. You don't really own your movies because you get them from a streamer. And so when you start looking at most of the other things, you're like, well, I don't really own my energy either, do I? No, we're essentially renting energy. And so the kind of mission of Mint was, how do you empower people with clean energy to basically own their own power, to have sovereign power over their energy, and to be able to generate enough power that you're not relying on anything else. And the cool part is it seems kind of like this really just good thing to kind of hope for and maybe work towards. And oh, that seems awesome. But one of our things that we have internally mainly is that if it doesn't make dollars, it doesn't make sense. And so it had to pencil, it had to be a financial opportunity that would make sense for those that we're working with and for ourselves. Because if you want to have an impact on the world, the business has got to make money at the end of the day. It has to survive. And so I've always been impressed with how Mint has approached that. We basically are technology agnostic, so it doesn't really matter what type of generation form. Traditionally, we've done solar just because I think that's the most ubiquitous, it's the easiest to work with. It's kind of, we have a lot of rooftops that are empty, parking lots that are empty. So it's like, let's fill some of that space with some energy generation, but it's developed over the years into something that's really incredible. And so in talking with Derek and the team, it was just, man, why wouldn't I join this incredible organization of what you guys are working on? Because this is the moment for energy. Like if you look at oil and you look at energy over the last, 120 years, this is a huge moment, is that we haven't had almost this industrial revolution moment in the last 120 years where the material that we use to generate power is changing fundamentally. And we're right in the middle of it. And I always thought that it was going to be kind of like a light switch moment where it just suddenly we do a different one. But it's been this very gradual move. And you saw, renewables start to cross traditional ways of generating power last year. You saw it actually fully cross. And it's not so much of an environmental move. Like, yes, that's a component, but like this is a societal shift that's going, no, there's actually a better way to do energy. It's not just about the clean of the energy. It's about just generating power in a more reliable, sustainable, replaceable, long-lasting way. And so it's been, that's how I got introduced to him, but it just kept going deeper and I was just fascinated by everything that we were working on.
Yeah, and I guess obviously we during our previous conversations we've talked about the triple bottom line and the way that Mint seems to go about their business. Yes, it's got to make sense financially for yourselves and for your clients as well, but that's not the whole story. So I guess that's harping back a little bit to your previous work and the environmental side of it. Was that a big thing for you? It wasn't just about energy is the future, it's dynamic, it's the environmental and sustainability and the people aspects of it as well?
People is probably the highest on that list. And that's both internally and externally. I don't know. At the end of the day, we're all people just trying to make it, just in the world. And so that same compassion we might find, someone else on the street. Why not apply that to business, both internally and externally? So inside the company and outside. I mean, we focus so highly on people. I may have mentioned this to you, but I haven't really I've worked with and for some incredible companies over the years, and I honestly have not met a team that is so incredibly capable at every single thing that we do as a company. And the
Yeah,
coolest part is a lot of everyone's backgrounds may not necessarily be in whatever they're working on. We kind of have this ethos in the organization that as long as you have incredible people, you can get wherever you're going. And we've all taken on really hard things throughout our lives. And so hard is really just a perspective. And so what we're doing in energy is hard. I mean, we're taking on a big uphill battle of really reimagining what the energy grid can look like. And we're not doing it against, an energy company or anything like that. We're actually working with everybody. It's just the idea of integrating into this big behemoth of a system is difficult. And
yeah,
we've just always believed that people are at the center of it. And the impact that clean energy can have on other people is, immense. If you look at generally utility rates, they're going up like crazy, and not just AI, we'll get there in a sec, but just in general,
sure.
it's always been going up. It's just going up at a more accelerated rate. And, the whole point of it is to give people opportunity. I mean, to do what they want, to dream what they want, to build what they want. In a modern world, energy is the thing that allows that. And so we're on a mission to do that. Yes, the benefit is you have infinite power. Yes, you have, a really good system that can operate autonomously. Yes, you can make money on the front end of the meter and actually, give power to the grid and get paid for that. But at the end of the day, we're helping people. And just happens to be the way we're doing it.
Yeah, I think it's very timely at the moment, isn't it? When you see the fragility of what energy supply at the moment. You see what's happening in Cuba where they have countrywide blackouts. What's happening in Iran as well. It causes all sorts of problems. It's and decentralizing this energy production and usage. That combination on site and sort of production of energy is, one of the key things, and the flexibility and I suppose, the variety of options that you have to how you get your energy, how you supply your energy, how you save your energy is just really brought into focus at the moment. So just tell me then, obviously we've got the philosophy, I think. What does MYNT actually do on a day-to-day basis? What types of clients is it working with? What's it actually implementing or servicing on a day-to-day basis?
Yeah, definitely. And I forgot to mention also part of that ethos, part of the company is that we are a B corporation, and a lot of that B Corp alignment that we do have is to really support that side. So I mean, as a B Corp, you are held to certain standards, and as an energy company, and I'll get into that in a sec as to how this ties in.
Yep.
It's a little bit harder to be a B Corp because you're generally you're in construction, you have materials that are a little bit more impactful to the environment regardless. And so a lot of those scores that go with the B Corp, we still meet B Corp standards and are a B Corp and have been and are continuing to be. But our standard of operation already has to be higher. So I'll start with that one. But then what we actually do, we design, build clean energy systems. That's the easiest way to talk about it. But really what that means is we're one of the few companies that are fully integrated. So generally in the energy space, you have a lot of people that will engineer a project, and then they'll go out and they'll find what's known as an EPC and they'll go build that project. So we happen to have literally everything in-house, from finance to engineering to construction. All of our crew is actually within the IBEW, which is the International Brotherhood of Electrical Workers. And so our capability to take a project from ideation to actually, built, scaled, commission, permission to operate, grid interconnected, we can do that at generally a better pace and also more consistency across the board because you're not jumping between different companies. And so we kind of understand that process from the beginning to the end. And I think one of the coolest parts for me is like, I don't come from an energy background. And what's wild is the amount of work that goes on between every department of the company. Construction's always talking to engineering. Engineering's always talking to procurement. Like there's always this constant communication going on. But the reason why I bring that up is it's such a complicated thing to get an energy system in the ground. It's actually kind of incredible. Like we see these solar panels just kind of show up and get plugged in. We see batteries show up and get plugged in. And to the public, you're like, oh, well, that was cool. But what did it actually take to get all of that in and everybody to make sure they have the right material, how they have it, when it gets installed, weather dependent? Our crews are incredible. I mean, that part has been absolutely fascinating for me, but that design, build, full just package, that I think is what differentiates us a lot. I mean, we primarily are on the West Coast of the United States. And so we're mainly in California, but we also can do, all the way up the coast, but we can operate pretty much anywhere with our union partnership. And that was something that came up last year because we're trying to think about really good ways that we can impact our workforce even more and to really lay the foundation to be an example for the future, especially for electrical workers, because we need them. We need them so badly.
Yeah.
To be able, we're honestly helping kind of not write the manuals, but we're working with the IBW on like, what does it look like to install clean energy? Because it is a little bit different. Like the principles are the same, but the workflow is a little bit different. We're trying to also just lay that groundwork down. And for us to be fully integrated, that's what allows us to do that.
Yeah, no, that makes a lot of sense. I mean, sometimes there's a lot of resistance to the actual construction stage of some of these projects. In the UK, for example, the solar farm schemes that are being implemented, generally they're going into greenfield sites. They're currently agricultural. They're not brownfield. They're not previously developed land. Roof-mounted solar panels. They have their issues if they're retrofitted. Obviously you can design your structure if it's a new build, but it's still interesting to see that there's this almost, it's the devil and the angel on the shoulders. You want that clean energy. You don't want to go through that construction pain. You don't want to lose that green land, But I guess you're working predominantly on existing sites, are you, or are you involved with new builds? What's the mix up there?
That's a great question. So we're primarily in the mid-size CNI kind of area. So that's mid-sized commercial and industrial. So it's those bigger warehouses, but it's not like that huge, AI server scale Microsoft side, but it's also not the smaller residential systems, because while both are needed, we found that middle area to not only be the most underserved side of the market, but also the area where we can actually make the most improvement, because traditionally their energy system has not been in their benefit. And also that is the lifeblood of most of manufacturing, is that mid-size CN. And so it is a lot of flat roofs, but to your point, yeah, the construction side, we got to make sure the roof is going to be fine to put the system in. There's also, is there room for the battery? How does that work with the municipality? There's so many interconnected things that kind of make it complicated, but that's why we do what we do. Yeah, the to your point though, on the green field versus brown field, I agree with you. I think there's two different, I want people to think about two different splits of energy. So you have energy systems that have traditionally, if you go with a centralized and decentralized grid. So most people think centralized power plant, whether it be coal fire or nuclear or whatever it is, there's one place where energy is generated and then it's sent outwards. That's kind of similar, because at any point you're going to need some sort of centralization of that generation method. But really, at the end of the day, we're trying to take that centralization and move it other places. Now, when that happens, you have a lot of people are like, well, now where can power go? And so now with solar, they say, well, let's make a big solar field. And yes, you'll have these big megawatt, 520, 50, 100 megawatt systems just planted down in greenfield. And yes, they generate a lot of power. But the problem is, every time you send that power out, you have line loss along the way. So energy is just going to be lost in the transmission. And our objective is to basically, how do you shorten that transmission? Because one, if you're wasting energy that way, that's not ideal. But secondly, a lot of things can happen along the way that make power not deliverable to a certain municipality. And then the last thing too is, we don't necessarily need the big systems anymore. Like in the United States, and especially in California, we have enough solar already there to generate enough for the entire grid for the day. Like we don't need any more of it. What we need is the storage and the distribution of it when the sun's gone. That's the key.
Yep. Yeah. And I think you raise a good point there, because I don't know what the infrastructure is like in the US, but in the UK, I think some of it is creaking a little bit, and there are definite pinch points along the grid. Even just producing the electricity doesn't guarantee that it's going to be available somewhere else generally, let alone on little issues on a day-to-day sort of basis. So yeah, I
There's
understand.
actually, there was a question, or there was somebody posed something to me that basically said that we, you could say probably a little bit of the UK and the US, but definitely the US, we went all in on a particular type of energy at the time. So lines, distribution, just the way that we set up our grid.
Yep.
We made a decision on that. Other countries skipped that generation. They just waited. And so in that time process, their grids are a little bit newer, a little bit more advanced. Ours are still a little bit older. And so we're just doing this patchwork, left and right, patchwork,
Yeah.
just keep it
Yeah.
alive.
Yep.
And I think get back to the earlier point in the beginning, was that, for 120 years, we've had it one way. Now we have the sweet opportunity to make it completely different. So whenever that happens, there will be this weird in between where you got a lot of people like, this is horrible. This is not going to work. And just long enough timeline, it'll start to play out.
Yeah. Yeah. I understand that. So, I mean, obviously we've talked about solar, but what are the biggest technological shifts that you're seeing at the moment in areas like the battery storage and maybe EV infrastructure, and I don't know, others like wind, maybe, I don't know.
Yes. So, man, battery is huge. So the idea of storage, and I think we've been kind of weirdly trained now by this with all smartphones and devices and everything. You're kind of hyper aware of that charge on your device. It's the same going to be with your house and your car and everything. Storage is that, we call it the panacea. It's the one thing that breaks through every problem with energy at the moment, is the storage and distribution. Batteries have been, well, they've been up against it last few years, I'd say. And that's mainly because it's the battery chemistry that's been around. I mean, we've been battling a little bit in the US of, you have lithium batteries as a technology. And yes, it takes some mining. And yes, it sometimes has a fire risk. But at the same time, we've put so many safeties in with those that like these batteries are incredible. And you have long form batteries, short form batteries that also go inside cars. We're having a big shift in battery chemistry coming in the next. Definitely it's here, but now from the technology standpoint, but from the manufacturing product side, it'll still take a little bit. Solid state batteries are going to be huge. Iron phosphate batteries are going to be huge, and just totally different chemistries. Salt batteries. I mean, you just have all these different chemistries that are able to store energy, because that's essentially, I want to maybe challenge the audience to think slightly outside of the box when it comes to what batteries are. Batteries are merely transportation for electrons. Like we're literally just nabbing them from somewhere, whether it be the sun, linear generator, however we generate it. We're just taking these little electrons and then we're pushing them somewhere else and we're just putting them in a backpack for a period of time. So if you think about it that way, it's now not so much about solar, lithium battery to this. It's now, it could be any form of generation to any form of store an electron and move on. And the reason why I mentioned that is you're having electrolyzers that are turning stuff directly from solar to hydrogen stored batteries. That's some incredible work that's starting on the front end where you don't need big hydrogen tanks and transportation for them. But the batteries are going to be the thing that make the difference. Because if you think about it in EVs, we've been a little bit trained with this, but it's not quite there yet. We're going to have this future that's going to start to develop, and where you have this idea of bidirectional energy. Energy is a currency, which I don't think we're used to thinking about. We think of a dollar as a dollar, but what if an electron could be a dollar? And I think that's going to be the key, because if it's the backbone of AI, I mean, you look at those credits that we burn in tokens, that really, those are your energy costs. How much energy does it take to solve the problem is how much we're going to charge you. It has has a little bit to do with the AI, but it's really the energy backing it. When we have this just battery opportunity, it encourages everybody to think differently about that use of energy. And so if you were to go to the store, for example, in the next 3 to 5 years, go to the store, plug in your EV, most likely you'll be able to make some revenue for yourself from going grocery shopping, just because the grid might probably need it. And if you got 20% in your battery that you don't need while you're grocery shopping, put it into the grid, make some money. And I think that's going to be a more common thing, even between buildings, in neighborhoods, in cities. It's just going to change that distribution of power. And that's what we're here to do. And we're also really excited about, because it also gives every person the opportunity to participate in the energy economy. And that, at the end of the day, is one of the biggest things. If you look at really the infrastructure of the entire world, energy companies are weirdly the most powerful ones. And it kind of democratizes that a little bit.
Yeah, I think it's a great point, and it's a mind shift, isn't it? Really, you've got to look at energy as an asset. You could suddenly have an asset. I mean, if new industry, construction going on, if they are having to put infrastructure in for themselves anyway to create their own energy, it's probably not that much more expensive to create enough energy for your neighbors as well, and treat it as, yes, you've got enough energy for yourself, but you might have a surplus at times that you can sell at a profit. So, and you're building in resilience for the future as well. Yeah, I think it's really quite refreshing to think of energy as an asset for all, rather than just a cost for the consumer. It's a great way to look at it.
It's always kind of been a cost for people. It's been one of those things where you just get your utility bill and you pay it, and you don't really get a choice in the matter when it comes to that. And I think one of the biggest impacts that I think we're going to have is that concept of it being an asset. Like, you can own your energy; it's an asset. And the more people that own more assets, specifically right now, this is probably the biggest opportunity right now, is to actually get as many assets as possible. That will actually lay the groundwork for the future. Because even just, I'll give you a peek into the financial side of a lot of these projects. Worst case, you're looking at like 10 or 11 year payback on some of these. The systems alone are meant to work for at least 20 years. You're just looking at that financial investment. You're able to guarantee your energy usage and costs. We usually will project model something out 10 years into the past, and we can go 20, 25 years into the future based on historical data. A little bit of AI probably in there. And when you run those numbers, I guess as a business owner, right? Let's say you're running a manufacturing company. and you have pretty decent energy load, it fluctuates here and there throughout the year. You know about how much you're going to pay. Well, when those rates go up, man, that's way more expensive than I thought. You can, as a business owner, you can control a lot of those levers and those things that go into your business. You can't control the energy. But if you can control the energy, now you have predictable energy usage that in 10 or 20 years, we've seen ones where, instead of 200,000 with a system, they're going to be spending 1 million on energy, in 15 years. And sure, that's
Yeah.
not now. And so it'd be like, oh, we don't need that investment. But what's it going to look like 10, 15 years down the road?
Yeah. And I think, energy price volatility, as we've seen even just over the last week or so, is not the friend of businesses, is it? That volatility, let alone the increase in price. You need predictability to make decisions, strategic decisions about, whether you go ahead with the next project or expand at a certain time. No business leaders want to take too many risks. So anything which reduces that risk is a good thing. But people have been talking about AI as being a risk really to the energy sector. Of course, there's a lot of discussion, shall we say, about how much energy AI is going to use compared to your bog standard Google search or something like that as a comparison. How are you seeing AI show up within the energy sector, with what you're seeing at the moment?
It's everywhere. I do remember I've used AI for quite a while at this point, just because of growing up the way I did and where I did. The moment it came out, I was like, hey, I'll try this. And so I've always been a fan of exploring what it can do, but I also think that it. I was very young at the time for this, but it reminds me of internet 1998, 99, where like the technology is fundamentally world changing. It is incredibly exciting. It is like magic. It's one of those few things where I typed in to ChatGPT for the very first time when it first came out, and when I pressed enter and it answered, it blew my mind. I went, wow, that's magic.
Yeah.
And I think the impact of it is what we're uncertain of, and we're uncertain of the timeline. So I would be pretty confident to say that at this moment, AI will 100% more impactful than the internet was for the world. The timeline on that, not quite sure. And the application of how that works, not quite sure. I think it's just one of those things where it draws a lot of energy. It does naturally draw a lot of energy, but big computers used to be entire floors of buildings, and now they're in our pockets. And so there's a natural adoption of technology where it will be, call it, more wasteful, especially in the front end. They've done so much work to make it exponentially better. I mean, the cost per token is so much lower now. Energy usage, water usage, all of it has gone down because you have economies of scale, and as it starts to scale more, it actually does get cheaper. So that benefit has happened, but it is insane amount of energy that's being put onto the grid, whether they're bringing their own energy grid, their own energy systems to their spot or not. Doesn't much matter, because at the same time, they'd be locking up the procurement that would be used for, the grid anyway. So you either need a rush of many different products on the market that can provide energy solutions, or you need somehow more generation and more things for the grid, or more decentralized. So if they're completely decentralizing their AI data center, then perfect. And then have a grid tie in where they don't need the energy. So the US is moving a little bit in that direction of like, whoa, you guys are bringing a lot of energy, so bring your own. That's been a little bit of the push, which I think is a good thing, because at the end of the day, if they're just kind of putting a straw into the energy and just sucking it all up for, some searches and saying thank you, who knows?
No, it's a good point. I think some of the uncertainties is around how much energy AI is going to be using is part of the problem for some people. I've spoken to some people where, they're very environmentally conscious and they don't want to use AI because they currently think that it is taking up, I don't know, 3 times as much energy to use AI as it would do for doing a Google search. And so I think, yeah, it's obviously, if we invest more in AI itself should be able to solve a lot of these efficiency problems with energy usage. Whether that balances out the energy that it's taken, it will remain to be seen. But it's certainly something that needs to, I don't know, become a bit clearer, shall we say, for a lot of people. But I think that fundamentally it's just not going to stop people using AI overall. It's just too impressive a tool to ignore on that basis. So, I mean, how have you MYNT
It's
been using AI? Are you using it? I don't know, knowledge management, for content production, for process automation? Is it really integrated into your systems, being where you're located?
I think that's a great question because I think right now it's not an if, it's more of a how you use AI at this point. Because there is a subset of people that are not using it, which I respect. Because honestly, I don't use it that much on my personal life anymore, and it's for a lot of those reasons. But at the same time, I think it's data in, data out is what it. They're very sophisticated data structures, is what AI really is. It's taking structured data and unstructured data, and using ones and zeros, and giving it to you in a way that you can understand it, and it can go in and read a little bit more into what you're doing. So the power is there. We use it internally at Mint. I wouldn't say we use it heavily. We use it more from a process standpoint, from a data crunching standpoint, if we need to crunch numbers. Not so much on our energy systems, weirdly enough, like that. We've already built just into our engineering, like our process is already that. I call it efficient. It's sometimes here and there for meeting notes and that kind of thing. But honestly, a lot of it is just, what are you taking away from this meeting that's actionable? But I think one of the big pieces is being able to automate a little bit of the content process too. I would say we don't do it for ideation. I think there's this really interesting line, and as a creative, I actually didn't expect AI to hit creativity quite as hard. I thought it would actually hit manufacturing first. So it's very interesting to be on the side of it where I was 100% wrong on that one, and me being the person who was affected directly by that being wrong. As a creative, it was very interesting to see it, but I see it as incredibly powerful for those that know how to use it best. So it's a process accelerator. It is not a replacement. If you think about where the data is coming from, it is inherently not true creativity or originality. It's
Yeah.
just synthesizing already existing data. And so the creative process is still very protected by the human. So the mind, and what can you do to get through a creative block? Done that, had some conversations where I'm like, hey, I'm just stuck on this creative concept. How do I break through it? But it's not doing it for you. And I think that's the automation side. It can almost work a lot like Zapier, where you just you're having stuff go in the background. That's basically all it's doing. I think there's a big trust layer that's not built into it quite yet. You're seeing a lot of that with the Open Clause and the Zo computers and all of these other ones that are starting to pop up of this new era of computing. I mean, you saw Jensen Huang talk about it at the NVIDIA conference last week. It was just this idea that we're moved into what a computer actually is changing. And so this newer type of compute, call it AI computing, is definitely new. We use it internally, but limited, because that was the recommendation that I was going to suggest is patience. Patience, patience, patience. I think everybody thinks that if they're not on it now, they're done. They're finished. The world's going to accelerate without them. They're going to be left behind. That's not the case. Like it will accelerate and it will be faster, and certain people will be left behind. Yes, 100%. That's always true. But the vast majority of people, it's going to take time to permeate. It will go faster than the computer, but it's not too late. And this will correct to a certain extent, mainly because you're starting to see the rubber hit the road a little bit, where organizations are going, man, was that as big of an impact as we invested in? And objectively, they usually say, yes, it had a huge impact. Did it have this much of an impact, this much financial investment? Not. Over time, that gap will get smaller and smaller. So that's the one to pay attention to. So it's not a matter of if it makes a difference, it's just how much and is it fit for your organization? And then it's prepping your organization for that inevitable time when it does start to automate a lot of things. But honestly, who wouldn't? Like, I move a lot of files for file management. Media and design is file management and file manipulation and communicating what happened with each file. A lot of those things that take away from the creative aspects of it. So in some ways it's really helpful, but I just think it's how you use it.
Yeah, I think there's some really good points you've brought out there. So, I mean, just going back to the start of what you were saying there, I think that, the energy use question around AI is probably not so much about how much energy, it's how much environmental footprint have you taken to create that energy. If you're using renewable systems, if you're creating batteries from more sustainable sort of materials in the first place, then, it shouldn't necessarily matter how much energy you're using if it's produced in a sustainable way. When you were talking about the creativity aspect, I think it's a no-brainer, really, isn't it? If AI is looking at everything that's ever been done on the internet and in various digital sources, inevitably it's all going to converge in certain directions, not into new ideas and new creativity. Yeah, I think your creativity side is going to be safe for probably years, if probably decades, I would imagine at this point. And I think your point about adopting AI is really key, really. It's about priorities. It's about return on investment. It's about minimizing disruption to what you're doing. It's about helping your business, not interfering with your business for the greater good. And some aspects are going to be easier to implement quickly than others, basically. And, people have got to keep up with it. You can't suddenly just change how everybody is working overnight. If you've never really got a working relationship already with how AI, you know, performs its tasks and well, and where it performs it badly, you're going to get caught out pretty quickly, really. So I think they're all really, really key points that you're bringing out there. But do you see, in your business in the sector? I mean, I'm presuming AI must be maybe already starting to help design or optimize energy systems, or is it still a creative problem that's human led? How do you see that?
I mean, I think the interesting part about AI right now is that I think if you were to take a battery system, for example, that's plugged into the grid, and part of what makes an energy system as efficient as possible is when it can do what's called load following. And so the idea is that as you're increasing load on the building, generally the way billing works, at least in the US, is if you pop into an energy usage kind of section or high energy usage for even 15, it'll bill you that amount of energy for kind of the rest of the month, because it's like, oh man, they need bigger lines, they need more maintenance because they're using more energy. So we're going to need to charge them more for the eventuality of, servicing those lines. You can, as you approach that, you can have a battery that deploys that energy to keep you below that line and keep your rates lower. And then at night does the same kind of thing. And so load following, if you think about it as what AI has been doing, for example, in the stock market, where it can quick micro trade, you're more or less kind of doing that with energy, where it's very quickly adjusting to energy usage, even faster than a human could recognize it. You're seeing that kind of in the technology. From the engineering standpoint, I mean, there's so many regulations and code and everything like that. And our team they've been doing it their whole career. So they don't really need as much of the AI help of like, how does an interconnection work in this area? Will it work? They kind of just already know. But I think the big part of the energy usage that we're trying to solve for other people is how do you understand your energy and then manage your energy accordingly? So some people may not need to run all their machinery all day long where they used to. There's a lot of machinery that is also getting upgraded from traditional forms of being powered, like diesel engines, to electrical engines, even in the manufacturing side. And so you just have a completely different way of doing things as well. And so it's not only the energy we're producing and storing and using for the building, but it's all the things that attach to that. So if you have an EV fleet, for example, that EV fleet has now got a charge versus they used to go off to gas stations. And so for them to actually come in and charge at their facility, that's a whole other different load capacity that maybe they didn't have before. And that future is coming as well. And so how do you build the infrastructure for them to be able to charge their vehicles? They're charging their vehicles at night, when the work day is over, you're going to be pulling energy from the grid at the highest rate that is available, because that's 4 to 9 p.m. If you're using it off of your own battery and you're charging your vehicles back up, there you go. You just use your system a little bit more efficiently. So that's the kind of way we're approaching it. I think AI it's going to be powerful, and it's already is. I think it's going to get more embedded into what we're already using. So if you're using an energy management software, AI is just going to get plugged into that. It's not that AI is just going to like come in and replace something completely.
Yeah, yeah. It all makes sense. I mean, you touched on EVs there. I mean, are you seeing, I don't know how big the businesses are that you're implementing schemes for, but is there a demand there for EV charging stations on site at these businesses for their workforce or otherwise?
Absolutely. Yeah. Generally there's a large percent of people that charge at home. That's the predominant case for most people, but I've had an EV and you gotta charge in public at times. And it's incredibly convenient to have it in an office. And so part of it is you're just laying down some more, especially if you're doing a more, solar battery, just what a power system that's not the traditional, just interconnected to the grid. You're just laying some conduit and putting stuff in there, and there are your chargers. I mean, you can do level 2s, you can do level 3s if you want to go big. Like we've done some actual like EV charging stations. So we have public infrastructure for EV charging, but we also do them at buildings. And I like that we do both because we're able to understand what the consumer is actually going after. So some, they just want They want speed and power when they're in public. Like they want something that's reliable, that's fast, that goes. And then at the office, they don't care if it takes a while, but they want it to be charged by the end of the day. But we are finding that, yeah, we're working with a company that's doing cold storage at the moment because they do food. It's literally a food organization that gets food out to everybody in the Bay Area. And they're an incredible organization. And they're looking to kind of lay down the groundwork for the future. So they're electrifying their delivery vehicles. They have to always be ready to deliver food. If there's a power outage, like food is critical. And so we've been thinking about their energy system as what happens if this is all that there is? How does this work? Then, okay, now let's assume you have power all the time. Now, how does it work? And then the benefits just keep stacking. But even at the basis of the level, having an EV fleet tied to their production, tied to an energy system that's all at their main hub, it covers kind of their energy needs across the board, which is huge.
So sorry, just to clarify there. So when you talked about level 2 and level 3, are we talking like supercharging, super fast charging versus lower
Yes.
rate charging? Is that what you
Yes, I
mean?
probably should
Yep.
have clarified. Yeah. Yeah. So level 3 is that supercharging. Level 2 is just those ones where you plug in, you're like, okay, that'll be 3 hours. That's fine.
Yeah,
Yeah.
got you. So obviously we're talking about industry here. I'm really interested to know what's happening for households in your part of the world. Is there a big push for domestic battery storage schemes, air heat pumps, obviously on-site solar on those properties as well? What sort of, I don't know, incentives or just demand and desire is there for that kind of thing there?
Yeah. Battery, I'd say, is the big push. Solar incentives they've pretty much disappeared, which I don't know is that's a bad thing. I know this is a little bit of a contrarian type of thought, specifically being in the clean energy industry, but because we, of course, like incentives, but I think the industry is mature enough at this point where it needs another incentive, which would be the batteries. The idea of a solar panel getting an incentive at this point, I think it served its purpose, meaning they made it a cheaper barrier to entry for commercial and residential to be able to afford solar, this new power generation system. That was accomplished. There's enough solar on the grid now at a good rate that people got a solid deal and we're able to get energy on the grid. So when the incentives go away on that front, it was kind of a hit initially, but for us, since we've always approached things of it has to make dollars and it has to make sense, the incentives didn't actually hit us that much. It really just expanded the time window of the payback just shortly. I mean, literally, I'd probably say less than 10%, maybe even less than that, is how negatively affected it made our financial models. But for the homeowner, I think the big thing is it is going to be battery storage. You can have the portable batteries. I think there's not a lot of, I don't want to say support, but we're still figuring out how to attach batteries. So like if you're are putting batteries, you can put it inside, you can put it outside. Do you have it, certain municipalities and areas, you can't have a battery inside or you can't have a certain capacity inside. So you have to have different units. So that part is getting kind of messy and needs to be unified a little bit. You do have a company who is actually the son of Dell Computers. He started a company called Base Power out of Texas, and they're basically doing the size of an aircon system, basically just on the side of your property, but that's a battery tied into your house. I'd say that's kind of where a lot of people are going because it's not only for the resiliency, but it's also for, just the capability of when there is an outage that your home can not only do what it's normally doing in that resiliency case, but if you have an EV, it can also work to charge that as well. Because a lot of the discussion when the power goes out is use your EV to charge your house. That's wonderful. But what if you have to drive somewhere and now you just used all the power on your battery for your house and you didn't charge that
Yeah.
thing back up? Now you got to walk.
Yeah.
And so that's where there's a little bit of challenge on that end.
Yeah. So it just out of interest then, sort of restrictions on having a battery within the property. Is this a health and safety matter? Fire risk worry? What's driving that?
A lot of it has always been based in fire risk. Absolutely. And that's part of the older battery chemistries. I think so. A lot of people have focused on the battery fires as the negative thing, which I mean, fair. Hopefully they never happen. But when you look at it at scale, it's not a big fire risk.
Sure.
Like when you think about how many other things light on fire, it's very, very low what comes from batteries. It's just because right now it's a little bit of the focus. The spotlight just gets turned right onto it and everyone's like, oh, this is horrible. And so we have to kind of fight against some of that and be like, no, it's actually not as difficult as and unsafe as most people assume. Yes, there are some accidents, but it's advancing so quickly in the chemistry and the safeties there. We're never worried about any of our systems at all.
Sure.
Some of the bigger fires that have happened, have been inside because there's been water dripping on the system.
Okay. So let's put it
And nobody
outside.
mentioned that part. Yeah, exactly.
Interesting. Okay. So I'm going to move on to some quick fire questions here for you. Just so personally for you, what technology are you most excited about right now? Energy or otherwise?
Tech, energy, or otherwise. I'm actually really fascinated by the material space right now. Personally, that was one of my incredible things I had fun with in media was material science. So if we're traditionally used to cotton as a material, could it be that it's made out of, crab shells? Could you make oil out of algae? Just all the different things that we have, if we can have a natural drop-in replacement, mycelium
Yeah.
is insulation on houses, like all that kind of stuff. Fascinating because I believe that circularity is going to be the secret to most things. If you can create your own
Yeah.
manufacturing loop, your own waste loop, feed it all, and then back it with energy, that's truly an integrated system that I think not only scales, but less impact and everybody wins. That's what I'm really excited about.
Yeah. I thought you were going to say something along those lines, actually, and I'd agree with you as well. I mean, the prospect of these salt batteries and obviously hydrogen power and such like, they have such promise about them that it's hard not to get excited about these, I must admit.
Yes. No, on the energy side, the hydrogen, all the different generation methods, that one actually, generation and storage, those are fascinating.
Yeah.
Just had to throw a different one in there.
Oh, I love it. I love it. Don't mind that at all. So if you could give one piece of advice to business leaders about energy strategy, what would it be? One takeaway.
I'm going to do 1.5. 1.5. And the reason why: one, find a way to own your own power. Doesn't have to be the way we're doing it, but just pay attention to your power more so than you have ever before, because it's
Yeah.
going to matter. And it's not just AI data centers versus you. That's the one. And then the half is be patient with that as well. So it's not that don't do it, but also don't, like, everybody's rushing to data centers, right?
Mm.
What happens when data centers aren't as needed because the energy usage is getting better? Maybe they don't need as big of a footprint. Maybe they don't need these huge buildings. Well, if you went invested in all that and then suddenly they don't need it, well, that's not a good investment. So know that energy needs to be an investment, but also temper that with some patience.
Yeah. That sounds like good advice to me. And my last one, I'm asking all my guests this. So one must read book that you'd recommend to our audience and myself.
I was given a book when I was in university, and it was called Never Eat Alone by Keith Fazari. That has been a book I've always recommended to people because it's the concept of building community with people no matter what throughout your life. I've been a big fan of that one, but I would say two others that I would suggest is Autobiography of a Yogi. Incredible book,
Right.
hefty, but life-changing. And then I'm currently reading Critical Path, Buckminster Fuller, and I think that he may be, well, I mean, he is my now personal hero. I don't know why people didn't talk about Buckminster Fuller enough, but my God, Bucky is an absolute legend with the way he saw the world and how he saw it being able to be improved.
Brilliant. I've got to find time for 3 books now, so that's a tricky one. Steve,
Well, those last two are big too.
oh gosh, that's it. I can find enough time for 6 equivalent. So, Steve, thank you so much for sharing this with me. I've really enjoyed chatting to you, and I'm sure our audience will enjoy listening to it as well. So I'm really pleased you joined me. If you enjoyed this episode too, please follow Aligned Minds on LinkedIn for practical tips and updates on future episodes of Aligned on AI. I'll share today's podcast details and details for you, Steve, as well on LinkedIn, YouTube, and Spotify. But thanks for listening or viewing, and we'll see you next time. Thanks, Steve.
Thanks, Karl.